Welcome back to section 7.1, page 3. So go ahead and pause the video and do your classwork and then come on back and we'll talk about converting from a fraction to a decimal. Okay, welcome back. So here, these problems, we have a fraction and we're being asked to convert to a decimal. And it even tells us how to go about doing it, long division. So actually this is a fairly simple process. We're good at this. So this is 71 divided by 125, okay? So we're going to go like this. We're going to say 71 divided by 125, okay? So when we try to do this, we can see that 125 does not go into 71. So we're going to have to put a decimal point here and add a 0, okay? The decimal point goes straight up. Now we're trying to say 125 into 710. How many times does that go? Well, you've got to kind of make a guess at it. So I'm going to try, when I look here, I say, okay, 1 goes into 7 about 7 times. But the 25, that's going to make it too big. So I'm going to start with 6, and I'm going to write it over here and just check it out. So if I do 6 here, 6 times 5 is 30. That's going to be 12, and 3 is 15. And 750. Still too big. So it must be 125 times 5. So 5 and 2, 12 and 1, 625. Okay? So we know that this is going to be 5. And we know that that's 625. Okay. So now I'm going to go ahead and subtract here. So I'm going to make that a 0 and this a 1. So 10 minus 5 is 5. And then I've got to make that a 10. 10 minus 2 is 8. So we have 8. That doesn't look like a 5 there, does it? We have 85. Okay? So now I bring down, I'm going to keep adding zeros until we end here. Bring down that 0, and I need 125 into 850. Well, look here. I have 6 gave me 750. So that must be what I want here. Let's put 750. And then we subtract here, and what do we get? Well, we get 0, 0, 1. And then we go ahead and bring down the next 0. Okay, so how many times does 125 go into 1,000? Well, right here at 6, we were at 750. So how about if we do another 2 more? I think that'll do it. So if we do 8, that's going to give us, do it off to the side here, times 8, 0, 4, that's 16 plus 4 more is 20. Carry the 2, that gives us 1,000. So that's exactly what we wanted. Okay. So what do we end up with? A remainder of 0. This is what it equals. So 71 over 125 equals 0.568. Okay? Now let's think about that. Let's do a sanity check on it. We know that 71 over 125, I should have had us guess before we started, but we have talked about, is it close to a half? Is it close to 1? What is it? And 71 is about half of 125, right? So it makes sense that your decimal is about 50%. Okay, so that's a good check. All right, let's try another one here. So this one, remember this symbol here means divide. So this is saying 2 divided by 27 or 2 divided by 27. Let's guess on this one first. 2 over 27. 2 is not very much out of 27. So we have, think about a pie. Think about a whole pie, and it's divided into 27 pieces, and you have 2 of those 27 pieces. You don't have very much, do you? So this decimal is going to be pretty small. Well, 27 doesn't go into 2, so let's put 0.0, okay, and put the decimal point straight up. Does 27 go into 20? No. So put a 0, and then add another 0. Does 27 go into 200? Yes, it does. So let's go ahead and figure out how many times. Why don't we start with like 27? We know it's going to be pretty high. So let's, 27 times 8, let's say. Okay, so 6 and 5. Well, 2 times 8 is 16, and 5 more is 216. So that was too big. So it must be 7. And this is just kind of a trial and error thing. That's 14,189. That's it. Okay, so 27 times 7 gives me 189. Okay, then I'm going to subtract. So, 10, it becomes, we go like this, 10, and then we make it a 9, and 10, it just makes it such a mess to do that. And that gives us 1, and that's nothing. Okay, then we bring our 0 down. Okay, 27 into 110. How many times is that going to go? Okay, well, not as many this time. We know 25 goes into 100 4 times, so that's probably about right. Let's figure out what 27 times 4 is. 8, 2, that's going to be 108. Whoa, that's almost perfect. So we put a 4 there. Okay, so we get 108. We subtract and we get 2. Okay, so now we're going to add, we're still not done, so we're going to go ahead and add a 0. And we're saying 27 into 20. It doesn't go. So we put a 0 and then we keep going. And we add another 0. Go down here. Okay, 27 into 200. This is starting to look a little familiar. That's how we started the problem, was 27 into 200. We found that went 7 times, and 27 times 7 is 189. Then when we subtract here, we have 1, 1, bring down the 0, and it's 110, and we know that that's going to be 4 times. Okay. And when we subtract, we get 2. Okay. Hopefully you're seeing the pattern. Do you see what's happening? This is just going to go on and on forever. So we're going to write 2 over 27. What does that equal? It equals 0.074, and then it repeats 0.74, and it's going to keep doing that. So we can put the bar over all of 0.074. Okay, so that's how you're going to do those problems. All right, so why don't we wait to do the classwork, and you can do that at the very end. Let's read these couple last things. Every terminating or repeating decimal represents a rational number. Remember, rational means fractional, okay? So if your decimal either ends or repeats, meaning it has the bar, then we're going to go ahead and be able to write it as a fraction, like we did on the page before. Also, every rational number can be written as either a terminating or repeating decimal. So that's kind of going the other way around. If we have a fraction, we can write it as one of these. Okay? So again, fraction. All right, definition. Numbers represented by non-terminating, meaning they don't end, and non-repeating, they don't repeat, decimals are called irrational numbers. Okay, so a new term. What are some examples of those? Well, some things you've seen before. Pi. This is 3.14159, on and on and on forever. It doesn't repeat and it doesn't end. So that's why it's an example of an irrational number. Some of you have taken algebra classes and learned about E. Again, non-repeating, non-terminating. Radical, square root of 2. It keeps going on and on and on, but has no pattern. So those would all be examples of irrational numbers. So let's kind of talk about the hierarchy of numbers. So we were looking at it in set notation. So the innermost, the most specialized, are the natural, okay? So natural numbers, and let's see if we can remember what those are. Remember, those are also called the counting numbers. So when you count, what do? You say 1, 2, 3, 4, etc. Okay? Next, the W is for whole numbers. Do you remember what we add in for that? We just add 0. Okay, so it's counting numbers plus 0. The I is for integers, so I guess I should be writing that part too. N, W, okay, sorry about that. I, integers. Okay, remember those. It means negatives and positives, but still whole numbers. So we go -2, -1. I need my dot, dot, dot. Forgot that. Okay, so dot, dot, dot. -2, -1, 0, 1, 2, on and on forever. Okay? And then Q, that Q stands for rational numbers, which equals rational or fractions, okay? Numbers. All right. And then real, the R here, real numbers. So what that is that would be our fractions and let's first call it rational and irrational so you can kind of remember it that way. Our rational and irrational numbers. Okay, but just remember that means fraction. Okay, so they would be numbers that can be written as fractions and all these crazy ones that we can't write as fractions because they don't end and they don't repeat. Okay, that's it for this section. Go back and make sure you complete your classwork, those last two problems.